Hello, today is Monday, October 7th, 2024. My name is Daniel Mullany, and behind the camera again we have Nico Greina. And today we are here to film a video source inspection of two fully remanufactured 870S spin wrench dryers. Our customer is located here in the United States, and their PO number ends with 5247. I will go ahead and get the process started and then discuss the systems as we go. Here we have 4-inch substrates in the top chamber. 4-inch substrates in the bottom chamber. And then our customer is running 4-inch in all of their chambers, but these refurbishments also require the purchase of 2 additional 4-inch rotors to fill out this system. And so those haven't been completed with construction yet, so we're just doing the demo here using our own 6-inch substrates and rotor that we have from stock. Okay. Again, standard 6-inch silicon substrates. All right, and so the first thing that I'll do for these 870S systems is I'm going to take a step behind and identify the serial number for our end user so they can compare on arrival if they'd like. This system is SRD 01661. This is SRD 01660. And since both of our systems are in rents, I'll take a moment to inspect the drain boxes and the drain area. Both of the chambers are looking good. I do not see any leaks anywhere here on the ground or anywhere near the back of the system, so everything is running properly. These systems are pretty standard 870S systems. They have the 3 normal options, which is DI water recirculation, anti-static, which is a static eliminator component here that's going to provide a static discharge during dry 2 to essentially alleviate any buildup that might happen of electricity in the chamber during the dry cycle. We're talking a slight amount of static electricity just from the Teflon spinning at a high RPM. However, that can be enough to attract particles in the room when the process is done, and it can also be enough to cause damage to any of your devices that might be sensitive to static. So that static deionizer is going to prevent any of that buildup from happening. We also then have resistivity probes on each of these chambers. The resistivity probes are located here on the drain box, and that's going to measure the resistivity set point of the DI water. That also gives you the ability to perform a what's called a Q-rinse step. And so what you'll do is you'll set a DI water set point, let's say something like 14 megohm, and if at the end of your rinse period that DI water resistivity set point hasn't been met, then we're going to go into a Q-rinse step, which will stay rinsing until that set point is met. In the event that the Q-rinse time elapses entirely, that's when the system will finish drying, but then will alarm at the end, notifying the user that the resistivity was never met. And so that's a good time to investigate into your system to try to figure out why your resistivity set point wouldn't be met in the first place. So we have both of our systems going through the normal process right now, which is these 2 chambers still in dry 1, these ones in dry 2. Dry 1 is typically a higher RPM step with a lower amount of time. In this case, we're going 90 seconds at 1800 RPM. As you can imagine, spinning at that high RPM is going to sling a lot of the water off of the cassette and substrates during the process. And then when we slow down to the lower RPM, which you might see on this chamber right here, we're going to let the heating elements finish the drying process. That's going to be primarily done from the nitrogen heater, but is also supported by the blanket heaters on the bowl, which we call the bowl heaters. Both of the blanket and the bowl heaters are monitored by our system, and you can see them actuating properly on all of these controllers here. You may also notice, even though it's kind of far from here, that the bowl heater is yellow right now. What that means is that the bowl heater has met its set point and is now off, which it's not sending current, but it's still performing its function because it's met its set point. After it cools down in about 20-30 seconds, the circuit is then going to close again, and we're going to send current back to that blanket in order to heat it back up. And that's how we kind of jump up and down above our set point, making sure that our bowls are being dried throughout the entire spin, rinse, dry process. All right, so everything's looking good so far as well. If I take a step over to investigate the chambers just visually, I can see that already the majority of the water has been dried up in the chambers, and so the processes are proceeding as we'd expect. And specifically, since we haven't seen any alarms, we know that the tools are running okay. The most important part about the refurbishment service that we're providing for this customer is probably and has to be our touchscreen controller upgrades. When you send a system to Sitek for refurbishment, we can retrofit in our touchscreen controller to your systems to bring it into the 21st century. We like to say that your next SRD is already in your fab, because all you have to do is send it to us for refurbishment, and when we rebuild it to like new condition and then add our touchscreen controllers, you're going to get the feel and performance of a new SRD with your existing equipment. Some of the features that are included on our touchscreen controller include a nitrogen purge saver, which saves typically at least $2,000 a year in wasted nitrogen that's currently happening on your systems. Current monitoring of both the heater blanket, the anti-static, and the N2 heater, or of all three. Data logging that's going to record the runs and alarms of any run or recipe change that happens on the system. A maintenance mode that allows you to individually actuate all of the components on the tool, and just general ease of function with using our system. Another good example would be our alarms page. Whenever you have an alarm on the system, you press the alarms page, which then pulls up a visual of all the components that can alarm. And if you select any one of those alarms, actual troubleshooting is going to populate on the screen in front of you live at the tool. There's no need for you to have to leave the fab, pull up a manual, call for support. Step number one is just going to be to select that alarm right from the screen and start the troubleshooting there. So you can figure out what's happening with your spin rinse dryer, leave the fab once, get the part that you need, and come perform the service to get it back up and running. Our goal is to make your experience with the spin rinse dryer as easy as possible. And that's why we say here at Sitek that we make wafer drying a breeze. Okay, so we've got about a minute to a minute and a half or so between all four chambers. So I'll take a second to discuss the refurbishment process that happens on any tool that comes into our building. First, we're going to completely disassemble the spin rinse dryer. That's obviously step one, because you cannot perform a thorough remanufacturing process without completely disassembling the dryer. Step number two is we're going to chemically clean and electropolish all the metal parts. Any previous processes that these SRDs were exposed to in the past, for example, a gold process, is going to be completely pulled out of the system through our chemical clean and then electropolish process. From there, we're going to rebuild the components that can be, which include the motor, the pneumatic valves, and the rotor upright positioner, or the RSP. We'll then replace all consumables automatically. Window, door seal, any gaskets, all of the tubing, the motor isolators, any part of the system that can show wear and tear over time is going to be automatically replaced. In this customer's application, we're also changing out all of the fittings in the system with FlareTech. So the goal for them was a priority on using FlareTech throughout all of their tools. We've done several refurbishments with them so far, and now all of their tools are coming back in the same format so that they can all be maintained with the same exact parts. Once the tools are then prepped, we're going to bring them into our final test area, which is where we are now. The tools go through a bunch more QC until they're finally filmed before shipment, which is the video that I'm filming for you guys right now. Our top chamber here, shown by our blue Success run light, has just finished. When I reach in, I can feel the nitrogen purging and warm. I grab the cassette, which is warm to the touch, and all of our substrates are dry and ready to go. I'll now proceed to the bottom chamber. Again, purging and warm. Substrates are dry and ready for the next step in your manufacturing process. Now to our 6-inch product. These look great as well. And our final chamber. Again, warm to the touch and ready for the next step in the manufacturing process. So, thank you for taking the time to view our video source inspection for today. If you'd like to check out some more of the resources on our YouTube channel, please do so. We have a bunch of great how-to and troubleshooting videos that will teach you how to maintain your spin rinse dryers. They're located right here on the YouTube pages that you're looking at right now. You can also visit our website at www.sitekprocess.com. But the thing that I'd like most is for you to just pick up the phone and give us a call. We'd love to talk with you about your experience with your spin rinse dryers, what problems you may be facing, and how Sitek can become your partner in improving your spin rinse dryer experience. Our phone number is 916-797-9000. And if you want to talk to me directly, just dial extension 2201. Thanks again for your time, and have a great day.